Hello guys. Today we will solve this room Voyage. Okay, so let's start the attack box and the lab machine. Let's maximize this window. Let's wait for it to boot up. Okay, our attack box is ready. Let's begin. So at first we will run a nmap scan. Nmap is C for default script, is V for version enumeration and region, and our target IP address, that is 151.139. Let's double check that. Yeah. Okay, so let's see which ports are open. It might take some time. Okay, so as we can see, there are total 3 ports open, 22, that is for SSH, port 80, there is a HTTP server running, and we can see Joomla. Joomla is a content management system, CMS, yeah. And then this port, that is 2222, this is also SSH, but here is one thing we have to remember, that the TTL is different. For port 22 and port 80, the TTL is 6464, but for this last port, the TTL is 63. That is this port is one hop further. Like, as many hopping occurs, the TTL is decreased by 1. So the first thing comes in mind is maybe this is inside a container or Docker. Okay, so let's keep that in mind, and let's take a look at the web page at port 80. So let's open our browser. Is my audio? Yeah, it's okay. Okay, so let me resize everything. Okay, so it was 151.139. Yeah. Okay, so as we can see, there is Cassiopeia, home, login form, and forget username, forget password. Okay, so first let's take a look at the page source code. As you can see, there is a, where is it? I just saw Joomla here. Yeah, Joomla. So this is a content management system, Joomla. Okay, let's take a look at this. I don't see anything very useful here. So let's go back to that login page and try to log in with basic credentials like admin. First, let's turn on that network tab, open that network tab, and log in. Okay, password and username do not match. Let's see where our request went. I think it was this one, index.php. Let's look at the request. Yeah, as you can see, admin. Anything else? Okay, so yeah, login failed. Now I tried doing a SQL injection here and it did not work. So we have to find another way to log in. Let's look at forget password and username. Please enter the email address for your account. Let's try to send a dummy email address like admin at the rate hm.com. Let's see. Okay, so register on this side. Yeah, so there is a possibility of email ID enumeration, I guess. But let's see, let's take a look at forget password. Did I just check that? Okay, let's try forget user now. Okay, in both cases we have to send our email address. Okay, I tried to play with this thing and none of this work. So one thing I want to show is there any known exploit for Joomla? Like, let's search Joomla exploit GitHub. Let's see if there is anything. And I looked at all of these and I found this one, which is the most recent one, CB 2023. This is information disclosure. Okay, so basically what it does is it will try to send request to some endpoints. Okay, and the vulnerability was those endpoints will disclose some information which without any authorization. Okay, so we can use this exploit from GitHub to get any necessary information. So let's try to clone this GitHub repo. Let's do git clone. What is the, I think this is the URL I have to give. Okay, okay, so it is being cloned. It's done. Let's see. Yeah, this one. So let's go inside that directory. Okay, now let's take a look how to use this exploit. Okay, so it is written in Ruby, I think, some kind of script maybe. Okay, so yeah, we have to run the exploit.rb file with our target URL, but we have to install these requirements first. So let's install this. Let's copy this and paste it here. Let's see. We don't need to deploy a vulnerable environment. Is it done? Yeah, it is done. So this is the file we have to run. So let's do ruby exploit.rb and then our target URL, that is this one, this part. Okay, so let's copy that and do this, paste it here. Hopefully it will. Okay, something, it just paste the page source code, I think. Did I is the command wrong? Okay, I think I have to specify the port, not the URL. So let's do this. Is that it? Yeah, I think it will do. Yeah, so we get some credentials here. Site name is tourism. Okay, database info, this is the important part. So we can say this is a MySQL database and it is running on the local host. So we cannot actually access this database from outside. It is inside their network, localhost, running on their localhost. But we get the username and the password. Okay, and the database name is JoomlaDB. Okay, so while doing this room, I will also try to visualize what is happening here so you can understand better. So let's go here. Okay, this was my from my previous. I don't know how to remove this. Let's just start doing it here. Okay, so suppose this is our target machine. Okay, and this is our attack box. Sorry. Yeah. Suppose this is our attack box. This is our target machine, and this one here is our attack box. So now let it move there. Attack box. Now the database is running in their localhost inside that target machine. Okay, and as we don't have any SSRF here, we cannot access that database from our target machine. From our attack box. Okay, so what we can do is let's try this username and password in every place. Okay, if these credentials is being reused somewhere, we might get in. So let's try it here. Root and the password. Does that work? No, it does not. And okay, one thing I want to show you. Let's enumerate any if there is any hidden directories present. Okay, so let's do gobuster. Sorry, dir, and our URL, that is HTTP, the IP address. What was the IP address? 151.139. OTT. The word list is I will use the .rb one. Peak.txt, I think. And let's also search if there is an extension present like Python, PHP, or JS, or basic text file. Let's run that. But oh, sorry, there is a typo. Let's run that now. And yeah, there is one interesting directory here, that is administrator. There are a few more. Let's try to see what that endpoint looks like. Okay, so here is also another login panel. Let's try the credential that we just got. Let's see if we can get into. And no, it does not match. Okay, so the credential is not correct for these two login pages. But there is another thing. There are two ports open for SSH, right? As we saw before. One is port 22 and another is port 22. So let's try to SSH into that. SSH root and 48.151.135. Is that correct? 139. Sorry. SSH. Yeah, that's it. Okay, so permission denied. We can't even log in that 22 port SSH. Let's try with port another one. SSH.p. That is 2222 port. Was that? Yeah. Then root IP address. Let's give that password. And we are in. Okay, so that worked with this SSH. Let's clear everything up. But one thing you have to notice is that this is not a typical Ubuntu machine like we see. Like this is here. This indicates that we are inside a container. We are not directly inside that host. I mean, yeah, technically we are inside that host machine, but we are inside a container. So as I was saying, if this is the target machine, okay, so this is a container. There might be another container. So let's just focus in this one. This is the container we are into right now. Okay, so yeah, we don't have direct root access to this target machine. We have root access to this container. Let's write it. Let's call it container A. Okay. So what we can do from here? First thing, let's do another nmap scan, and Let's look at what files are available. Okay, nothing. Let's see if we can get any hashes from here. Yeah, it dumps all these hashes, but I tried to run John the Ripper, but that did not crack any hash in this. Okay, it was just a waste of time. So we can't get any other credentials from this. Okay, so what I'll do is let's check the IP address. This is the loopback and this is the main IP address. Okay, so as you can see, this is the IP address of our container. Okay, and there is a subnetting. Subnetting 24 means 888. That is, the range is from, this is the network address, first three part, and this is the host address. Okay, so let's try to run a nmap scan on the whole network. Okay, so we want to see if there are any other containers that is available. To do that, we'll do nmap basic SVS CSV, and then reason we will do the whole network. So for that we have to do 192 and 0. Let's say okay, so this is our IP address of our container A. Let's write that down. 192 168 110. Okay, let's zoom it a little bit. Okay, so let's see what we got here. Host seems down. Okay, blocking our ping probes. I don't know why it failed. When I did that, it worked. How can I scan the whole network? Sorry guys. How to run a nmap scan on all hosts? I think that was SN. Nmap is in like this, and then 192.168. Oh, maybe we have to write the IP like this. Like this, I think. Yeah. So here is what's happening. What SN flag does is it does not send any packet. It just checks if the host is online. Okay. So as we can see, how many hosts are online. This one is our broadcast channel, I think. Yeah. Another one is this one. Okay, so this one is another container that is present in the same network, and this one is our initial container which we have root access to right now. As you can see, this is the IP address of our container. Let's see, IP address inet. Where is that? Yeah, as you can see here, look at the last octet 10. That is, this is our same container. Okay, so there is another container, right? This one. So let's run a nmap scan for this one. Okay, so what we'll do is nmap. Now we'll do basic nmap scan that we do always. SC for basic default split, SV for version information, region, and IP address 192.168. Let's see what we get. Okay, so yeah, now we know there are at least two containers. I mean, two containers as we saw. So let's draw another container here. not like that. Yeah, I'm sorry guys, I can't draw properly. I'm just doing this so we can visualize and understand better. Okay, so let's call it container B, and this is IP address of container B, that is 192.168.100.12. Okay. Okay, so we are right now, we are inside this. Okay, and we are running a nmap scan on this one. Let's see what we get. It's still running. Okay, another thing I want to tell you guys is that by default a container can connect to outside internet. Like if I am inside this container, right, I can connect. If I start a listener on my attack box, I can connect from here to my attack box, but the vice versa, like the opposite, is not possible. I cannot run a listener here inside container A, and from my attack box I cannot connect to that. It's for security reason. I just wanted to tell you that because I tried to do that, it did not work. Okay, and let's see for scan. Okay, yeah, it's done. Let's see what we got here. Okay, so the port open is 5000. Only one port, I guess. Yeah, so something is running on, it is a HTTP server, I guess. It's not sure what the server is. Yeah, but something is open on port 5000, so let's check that. But the thing is, how can we check what is running on port 5000 of another container? Because we are in target machine, right? We are here. We want to see what's running here. Okay, so to do that, we can do one thing, that is, if we can, okay, another thing I have to tell you guys here is that there is a port, right? So this is port 5000. I don't know why it's okay. So port 5000 of the target machine, and this is port 5000 of our attack box. Okay, so okay, I will be honest with you, I was confused. I don't know how it works. Okay, whenever I send something to the 5000, sorry, this is 50,000, 5000 of target machine, it is automatically sent to 5000 port of container. We don't need this, sorry, I don't know it, port 5000 here. We need that here. Okay, can I copy this? Copy. Okay, paste. How can I paste? Okay, forget it, whatever. So whenever I try to send a request to the target machine port 5000, it is forwarded to port 5000 of the container. I don't know how. My case is that the container is mapped that way, that whenever it can, it's like a proxy, right? Let's, I don't know what's happening. Okay, let's just delete that. Okay, so it's like a proxy. Whatever I send from uh, target machine port 5000, it gets sent to the port 5000 of the container. Okay, I can show you guys. Wait, can I show you guys? Yeah, I can. So let's do one thing. Let's run a listener on our container on port 5000. Okay, so we'll do netcat lnvp port 5000, right? Okay, netcat is not found. Okay, let's do a Python server. I think Python is installed. Let's do 5000. Okay, no, first let's do 1234, a random value. Okay, it's running. Now let's go to our attack box and try to connect to the IP address of target machine. Okay, not the container. We are trying to connect to the target machine on port 5000. Let's do that. To do that, we will go, let's do a basic curl, I don't know, like this. What is the IP of our target machine? That is 10.48.1. I forgot, sorry, 1511.39 on port 5000. You see, we can't connect to that. We don't receive any request here. Now let's do the same thing with port 5000. Let's stop that. Let's do 5000. Here also let's, okay, sorry, first time okay, sorry, my bad. So let's do that again. The mistake I did was I was running the server on 1234, but I tried to connect on 5000. Let's do that again. My bad, guys. Let's run that server on 1234 and try to connect to that. It will fail. Yeah, as you can see. Now stop this one. I'm sorry. I know, guys, this is being very boring and long, but I just want to explain things with where I stumbled upon. Okay, so let's do 5000. Now if we do this, yeah, you see we get a GET request. So this is what I am saying. Other ports does not work. Only this one works. 5000. So the point of explaining all this was we already have a way, a channel from our target machine to the container array. Okay, let's draw that. Oh no, like this. Is there no ruler or something? Okay, I don't know how to do this straight line. Yeah, like this. Type straight. Yeah. So we can connect from our attack box to container array via the port 5000. That is not a problem. Now the previous problem what I was talking about is how can we get the container B? How can we connect to that? To do that, we can create another proxy. We have to create another proxy here. Let's say if we can create a proxy here, then basically what we can do is we can connect from our attack box to container B. You see how we are trying to connect to container B, right? We are already connected via port 5000 to container A. Now if we create a proxy here between container A and container B, then we can directly access that web page, right? Because our browser is in our attack box. Okay, so let's do that. How can we create a proxy here? We can use socket. I think you guys know what socket is, and let's just put it there. So let's create a proxy between our container A and container B. Okay, to do that we have to, I don't remember the exact syntax, maybe socket TCP listen 5000 and what was that, fork use trace. Did I took note? This is where I take notes when I solve the room. I solved it 2 days ago. Let's see if I have that. Yeah, I have that. TCP, the IP address and the port. Okay, socket. The IP address is 10. Okay, which IP address do I have? Oh no, we have to put the IP address of container B. Okay, this IP address here. So we will do 192.168.100.12, I think it was. Yeah, 12, and the port will be 5000. Okay, so right now after executing that command, what will happen is anything that comes in container A port 5000 will be forwarded to port 5000 of container B. Okay, that is what we are doing. So let's run that. What exactly 2 address required? What did I do? Okay, okay, let's just copy this and see if that works. Okay, so there was a syntax mistake. There was no comma. Okay, let's run this. I think it will work. Is it working? Okay, let's try to go to that container B port. Which port was that? 5000, right? Yeah, so let's try to access that page. Let's do HTTP 1. Okay, where do we go? Like container B? I cannot access the IP address of container B though. Like, oh yeah, our goal is to send request from our attack box to container A, we don't have to think about container B. There is already proxy there. Okay, so I have to send to container A. And how can we send to container A? We just have to send on port 5000 of target machine IP. Okay, so to do that, we'll do 10 48 5000. Yeah, as you can see, this is a secret point. Guys, remember this page is on container B port 5000. Okay, but this is the process how we are getting there. Okay, I just wanted to clarify that. Okay, so let's see what this page source does. It's a small code. Let's see if anything interesting here. Any script file or JavaScript file? No, nothing. Login form method is post. Okay, username, password, submit. Okay, no fancy thing, just basic login. Okay, is it possible that the password we got from the beginning, we can use that here? Let's try username. Let's see. Okay, it works. Welcome root. Okay, so let's see if anything interesting here. Wait, guys, do you see that I put the username root, so here it says welcome root. Okay, what if we, but we don't have credential of, okay, what if we try to log in as another user? Okay, how can I do that? I have to clean the cookies, I think. Can I delete all certain cookies? Okay, and then reload this page. Yeah, so let's say we do admin, and let's try password admin. Okay, yeah, that also works. And as you can see, the username we are giving is being reflected here. So first thing that comes to mind is SSTI, right? Okay, so let's try to do this again. Let's clear our cookies. And refresh that page. Wait, what? I should go back to the login page, right? Okay, it's not working. Let's do that again from beginning. Okay, it's stuck here. I don't know how can I go back to that login page, I think. Let's say, I think is there cache being cached, let's disable any cache file. Storage network, disable cache. Okay, now let's go to storage and delete all our session cookies. And then, yeah, now it works. That was due to cache file, right? So let's try to let's see, how to check for just here, right? Let's do basic one, password. Okay, the thing is they don't check for password, any password just works here. Okay, see, but the thing is it don't execute this math, right? So it's not SSTI, but something is being done here. As you can see, the input is being reflected. Let's check our cookies, or if there are any JWT token cookies. Okay, let's take a look at this cookies. Let's go, where can I just put it there? And okay, so as you can see, this cookie is probably base 64. Yeah, it is base 64 because I don't see any other letters except A to E or F. Yeah, so let's go to our friend CyberChef and paste that cookie here from base 64. Wait, is it hex or, oh, sorry, my bad. I am confused. It's not base 64 encoded, it is hex encoded from hex. Yeah, now you can see some of the thing makes sense, but other are just binary or gibberish. Okay, so one thing comes in mind is deserialization attack, right? Because the how it looks is the data we are giving is being serialized and then deserialized. So we can do an deserialization attack. Now we have to know which deserialization is occurring here. So let's go to back to our attack box and let's see, is it even recording? Yeah, it is. Sorry guys. One thing I want to show is when we did a nmap scan on our container v, okay, we saw this. What is that? Python 3.3.10.12, right? So it might be a Python serialization, like using pickle. You know pickle? Pickle is used for serialization and it is vulnerable to deserialization attack, right? So let's try to do that. What we can do is let's go to a Python ID. I don't want to use my VS Code for this. Okay, this one is from previous video I was recording. Okay, so what we can do is if we deserialize the cookie we just got, and if that makes sense, then we know for sure that it is being serialized using pickle, right? So let's do that. I have that code I just wrote. I will upload all this to my GitHub and I will link that to the video. You can see it from here. So this is the part, code to deserialize. See, so let's change the hex value. Wait, can't see, there's something wrong. Okay, so what hex value do we have? Let's go to CyberChef and copy this. Let's see. Okay, now let's deserialize this thing. Yeah, as you can see, we get our username and revenue. This thing right here, revenue, right? So these two things are being serialized and then deserialized. Okay, so as right now we know confirmed that pickle is being used, right? So we can send our payload as serialized data, and when the website try to deserialize it, maybe our code will be executed. Okay, so this is the code that I got. Okay, so we will serialize this payload, right? And there's one or two things I want to explain. When I was doing this, what I did first was, let me show you. Whenever I try to do a command injection in Python, I do waste.system, you know that. But the thing is, waste.system will execute the command, but it won't show you the output, right? I can also show that to you guys, like if I run a listener on our target machine, and here I do like os.system, and then I try to connect to our target machine. We will get a request back. We will receive a connection, but we won't show the output. We won't see that output. Okay, sorry, my English is not good. But what happens when we use os.popen is it will return a file like object connected to commands output. Still need to call read on that object. I'll show you how that works. Okay, so let's serialize this code. We are trying to execute the command who am I. Let's do this. How is it so small? It was not like this though. Okay, sorry, my bad. Okay, so let's change our cookie to this. Session data, this one. Let's delete this one. We don't need this one. I don't know how that came here. Okay, save that cookie. Now one thing, guys, remember, do not refresh this page. Okay, if you refresh this page, what will happen is the cookie we just saved will also get changed. Another cookie will be there. So okay, so you don't want to refresh. I was stuck here for some time. Just do this. Go to the URL and just press enter. And as you can see, the command got executed, but we don't see any nice output. Like we can't see the output, read that output. That is because, as I commented here, it will return a file like object. Okay, we can't just see the output. To see the output, what we will have to do is subprocess.check output. Let's import that. I have already imported that, and let's instead of OSP open, let's do this. Subprocess. Guys, I have to do it faster. My laptop is like burning hot right now. So check output. And the reason I am using this comma like reduce, the main function which is exploited in this pickle deserialization is this reduce function, and it expects tuple. I have put all the comments. When you need an explanation, you can check it out from my GitHub account. Okay, so let's run serialize this code. take that cookie, let's change it. Save it, do not refresh. Yeah, as you can see, we are root. So we got command execution, right? Command execution, sorry. So how can, for better, to get better look around that container, we have to get a reversal, right? So let's go to our attack box and start a listener. Let's do which port, I don't know, 4446 maybe. Or should I do Python? No, let's do netcat, stick with netcat. And we have to change the command to something that will connect back to us. Okay, so here is one thing. I have tried both process and I was stuck here for some time because I don't know how one worked and another one did not work. So you can use any of them. Okay, you can also use, because guys, remember at first I told you Voyage.system will execute that command, right? We just want we just cannot read the output, but we don't need any output here. We just want to connect back to our target machine, so we can technically use Voyage.system here, right? So let's use this one. You can also use the this one right above. Same thing, just we are using different subprocess.popen, and here we are using Voyage.system. Let's do this. Okay, first let's change it. We have to change our IP address though, our attack box IP address, that is 4885.203. And the port is 4446. Okay, so now let's copy this. You can use any of the payload. I am just using this one, and let's paste it here and serialize this. We will get a hex. Copy that. Make sure your listener is on. Go back to cookies, session cookie, paste our new cookie. Do not refresh. Do this, and as you can see, we get a shell, right? So guys, as I was saying, first we were inside container A, right? But now we are in container B. To get inside container A, what we did, we used there was a password reuse, like the root and another password we got. That was reused in this SSH. So we got in container A, and then we exploited the deserialization thing in container B to get inside container B. So right now we are inside container B. Okay, so let's take a look at what we have in container B. Okay, I don't know where the flag is. Yeah, as you can see, there is a user.txt. You can just get this flag. I am not showing you the flag. Okay, you can get the flag from here, but we are still not done. We just got one flag. We have to find another flag. Okay, so we are inside container B, right? Guys, remember, we are not inside target machine yet. We don't have root access of the target machine. We are just inside a container. As you also at the beginning, the challenge says something in pentest. Sometimes in pentest you got root access very quickly, but is it the real root or just a container, right? This was the clue the whole time. Okay, so let's see what we can do from here. Okay, first thing, let's try to stabilize this shell because I don't like this one, and I also don't remember what was the command to set stabilize. Let's, guys, I am very bad at remembering any commands or something. I just use AI or search it. Stabilize cell. You see, that is in my history. I did the same thing when I was solving this room too. Yeah, so this one I'm not wasting any time to type that, just pasting it. My laptop is already very hot. Control Z to background that. Oh shit, I think I messed up, guys. You know what, let's do that again. Control Z. Okay, now that is in a background. Let's do this thing. And let's foreground that. Yeah, we are halfway there. Okay, so export term extra. Now we need to know our terminal row and column. Okay, to do that we can do, what was that, to city wise size 2991. We have to do like this, rows and columns. 2991. That's it. Yeah, now it works. I can go back to my previous command and move back and forth like this. So this one is better. We can work better in this shell. Okay. So as I was saying, let's see, is it still recording? Yeah, it is. Okay, guys, I have to do faster. So as I was saying, we are inside container B, right? Yeah. Now let's find some way so we can get root access of the target machine. So when I was enumerating this machine, like I was trying to gather information about everything, I found one thing very interesting. That is, let's do this. Let's list all the files. Bash history. This, guys, remember, whenever you have a shell to a machine, always look for this, right? Sometimes it is very important. I was just ignoring this again and again. Finally, I take a look at this and I got some clues. So let's get that. Okay, guys, another thing I want to say is I told you guys like how our attack box can directly connect to the container with port 5000, right? This one I got from a write-up. I was stuck here. I could not connect to our container. But the write-up there did not explain why only port 5000 works, why not other ports work. And I don't know why that. I asked AI, it said that most probably when this container image was created, it was pre-mapped with the target machine, the host machine this way. So if any of you know the real reason, you can just tell that in that comment section. I would really appreciate that. I want to know how am I supposed to know from on the first place that only port 5000 will work, right? So that's one thing. Okay, so we are seeing the bash history. Now, the first thing that I notice is this one, .ko file. This .ko is a kernel object, right? So, and this says ref shell, reverse shell probably, .ko. So, it's a clue. It's indicating you to kernel object. So, if you guys don't know, there is a exploitation that is kernel module loading. What it does is, okay, let me explain how it works. Okay, so let's make it bigger. Let's remove this. Okay. So this is our target machine, right? Target host machine. Now this container don't have direct access to this host machine user space. The user space are isolated. Okay, but remember guys, container and the host machine both share the same kernel. Okay, let me try to show that. There are more. Okay, there are more shapes here. Oh, shit. Why is it so big now? Just remove it. Just forget that I'm doing this with this one. All right, so this is our kernel. Okay, so the target host machine, the container is running on, and the container, each and every container A or container B, everything, they share the same kernel. Okay, so if somehow we can inject a code or execute a code on the kernel level, that is ring 0, then that code is being executed in the host machine kernel, not inside the container. Okay, so whatever we put the payload, that will be executed inside our host machine. So if we put a payload, let's say a reverse shell payload, right, that is being executed in the kernel of the host machine. So when we receive another connection, the connection is from the host machine, we will get direct access to the host machine. Now how can I know that if I have that ability to get code execution directly inside the kernel? So that thing, I think capsys, or I took note of the, yeah, capsys module capability. Okay, as I said, container escape via kernel module loading and capsys module capability. This capability is on for your container, that is our container B. Then we can do that. This capability allows a process to insert, as you can see here, process to insert code directly into the running kernel. Okay, so let's check if we have that capability enabled, right? How to do that? I think cap sh print and look for capsys module. What is it? A double print? just to cap as such. Okay, and so I think the case sensitivity thing, we have to put it in small cap. Yeah. So current and bounding set, yeah, the cap sys module capability is enabled. So first thing, we are confirmed that yeah, we can do the kernel, we can inject the code inside the kernel. Okay, so first we have to build that executable that will be executed inside the kernel, right? That ko file, that is kernel object file. To do that, we have to first we need a source file, a C file. Let's call it payload.c. We will have a C file that will do all the logic, like how we will receive the reversal, and then we will have to compile it using the kernel headers. Like, I know this is kind of complex. When I was doing it first time, I previously never I did the kernel object compilation, so it was kind of complex, but you can see it. I think I have, yeah, as you can see, I took note of that. You can check if capsys module capability is enabled here. And another thing, okay, so another thing is let's check what is the kernel version of our host machine. I'm not talking about the content. The kernel version is same for both because they all share the same kernel, right? So let's do that. Let's delete it now. Let's do, okay, so this is the kernel version, kernel release number or whatever. Okay, remember guys, this is that. And to build a kernel object, we will need kernel header files, right? So let's check what header files do we have. The header files are located in, I think, lib modules. Oh shit. And then, yeah, so the header file we have, look, they are defined. It is 1031, the kernel version, right? And we have header file 1029 and 1030. So how can we build the kernel object for this kernel that is 1031 using this header? We have to find a way, right? So what we can do is we will trick the machine. We will build the kernel object using this, the nearby, the latest, I mean the most recent with respect to our kernel version, this one. We will build the kernel object using this header, and after the compiled file is ready, we will change only this part 1030, this part to 1031. So the kernel will think that it's built for that kernel, but actually we are using a different header, different but related header. I know it probably doesn't make any sense for the first time, but let's do this and I will show it. Okay, so yeah, as you can see what kernel header we have, I already showed you. This is the kernel header files, two files we have, but that's not the same exact as the kernel we are dealing with. Okay, so let's take a look at the source code. I'll just copy it. By the way, I got this source code using AI. I did not write it fully, and you can see you have to put your attacker IP and port. Let's do that from here because it's easier to edit everything here than inside Nano. So what is our attacker IP? I think 448 8523. Oh no, not here. And the port we already have 4446, so let's do 4444 maybe. And anything else? No, so this will do, I think. Let's put that inside our source code, paste it here, and save it. Okay, now we have the source code, but we have to compile this. To compile this, we will use makefile because we will need kernel header to compile, so using makefile is easier. So I don't know, makefile. I also have the makefile here, but I will explain to you a little bit. Wait. Okay, this is the makefile, right? So guys, if you are manually like typing this thing, remember you have to put a tab here, this part. You can't just do space, right? Okay, so let me explain to you. Guys, look, see, what are we using? We are using this version. This is not the exact kernel version, but this is the most recent we have kernel header. So we are using this one, but after the compilation is done, we will change this part. We will just put 1031. Okay, so let's save this and now just compile this. Missing separator. Stop. What happened? Stop. Oh, sorry. What happened to this part? Why is it like this? It just goes invisible. I don't know why. Let's try again. What is that? Missing separator. Stop. How is that coming to her? Missing separator. Let's ask AI. The missing separator stop error never is caused by using spaces instead of. Okay, so I am just making fool of myself. Whatever I told you, I did exactly the opposite. I used space instead of tabs. Actually, I just pasted it, so it's not. Let's do this. Yeah, so because I pasted it, it took it like a space, but we have to do tab like this. Okay. Okay, I think it will work now. Guys, my laptop is like burning hot. What? Ah, hmm, what's happening here? Is it like those new line? Ah, where did I use space again? I used tab here because of this. Guys, I don't know what's going wrong here. Can I give this to the AI and see what's wrong? I am still getting some errors. Let's see. Make variable? What is that? Oh, wait. So this has to be a make variable. Okay. I think I did something wrong while taking notes. Let's do that. I think like this, right? Hmm. Let's do that here too. I don't know why I can't see it. Like maybe my nano is not configured properly. I don't know. Let's hope it works this time. Oof. No, guys, what's okay? Let me pause this video. I'm going to check. Okay, guys, so it worked, but I don't know what I was doing wrong. Like, this AI gave me this part, right? I did the same thing, except maybe this part I was missing, PWD. right? Like we have to first execute that pwd command. Whatever output we get, that is passed here. I don't know if you guys know, you can explain to me. Let's ask it here. Okay, undefined variables pwd and pwd directly in the recipe without defining pwd in the make file. Oh, okay. Okay, so here I am using pwd, right? I am using it, but I did not define that pwd. What is this pwd? So we have to first do like pwd is a variable. That is, first we will execute shell pwd, this, right? I think that's what it says. Yeah, shell pwd. Yeah, so that was the problem. I think I just learned another new thing. That was I doing mistake. Okay, so let's see. Do we have that ko file? Yeah, we have, as you can see, refshell.ko. So our kernel module is ready, right? We now have to just execute it. So, oh no, there is another part. Like as I said, we compiled this kernel object using header file that is 1030, but our kernel version is 1031. So we have to change that. To do that, we will do a, I think said I. Yeah, said I. So this is the thing. It will change the, it starts with S and G, and it will change this part with this one of that file. Okay, so I'm just going to copy this and paste it here. Guys, you understand, right? Like the compiled kernel object, I am changing only the kernel version, kernel header version, not kernel header version, the kernel version. So it works with the kernel of the host target machine. Let's do that, and then we can run it. To run it, okay, first we have to set up another listener, and I forgot what was the port I used there. Maybe 4444. Yeah. Okay, and ko thing is the ko object, kernel object is run. I think how is it run? Ko kernel module. There was something ins, I think, ins mod, right? Ins mod, that ko object, I forgot it. So this ins mod is used to run that kernel object file. So let's do that. I think it executed, and yeah, we get a shell. So guys, remember, right now after this step, now we are inside the target host machine, because when we ran that ko file inside container B, it was ran inside the kernel, right here, and the kernel is of host machine. So that reversal was coming from that target host machine. So we got direct access to the target machine, right? So actually we escaped the container. That was the whole part of this challenge. It was a fun room. So let's take that flag. Yeah, you can say root.txt. I'm not getting it. You can do that exact steps and get that flag, the root flag. And if you guys have any doubts or something I did wrong or can be done in better ways, or the question I asked about, like this one, how was this? Like, is this predefined? Is the default port that is pre-mapped in container and host machine? I don't know. So if you guys can answer that, I will really appreciate that. And yeah, thanks for watching. Bye.